Good morning, students. Hope all are you well. So today we are going to discuss a new topics related to the belt drive, and this topic is centrifugal tension. In this topic, we will discuss the effect of centrifugal tension on the power transmission of any kind of belt drive. So let us start with the topic. So you can see that in the case of our belt and pulley drive, our pulley is rotating in either clockwise or anti-clockwise direction. And this is the common concept whenever a body rotates in a circular direction, it experiences a centrifugal force. So the same concept is also applicable in case of belt drive system in which our belt is moving over a pulley. The pulley is also moving in circular direction, so that's why it also experiences a centrifugal force. Due to this centrifugal force, there is a production of centrifugal tension. So overall tension of a body, that is the belt drive, will increase due to this centrifugal tension. So the effect of this centrifugal tension is to increase the tension on both sides, that is tight as well as the slack side. So let us suppose we have a driven pulley, and driven pulley we take specific area PQ, and this area subtend the angle d theta at the center, and the radius of the pulley is small r, and this Fc is the centrifugal force and Tc is the centrifugal tension on both sides of the pulley. So due to the effect of this centrifugal force, the tension in the tight side of the pulley is now T1 plus Tc, and tension in slack side of the pulley is T2 plus Tc. Earlier the power transmission was T1 minus T2 into V. Now the power transmission will be Tt1 minus Tt2 into velocity. So the power transmission will be, put these value in this equation, T1 minus plus Tc T2 plus Tc into V. Now this Tc and Tc get cancelled out. So the power transmission will be T1 minus T2 into velocity. So from this equation it is clear that there is no effect of centrifugal tension in the overall power transmission of belt drive. Also we only consider the effect of centrifugal tension when the velocity of the pulley is greater than 10 meter per second. So we will not calculate any power transmission, the effect of centrifugal tension on the power transmission when the velocity is greater than 10 meter per second. Now the next thing is the maximum tension in the belt. So we know the tension in the belt is stress into width of the belt multiplied by the thickness of the belt, where this term is the area and this is the stress, and it depends upon the type of material of belt we use. So in this way we can calculate the maximum tension in the belt. So suppose this is the cross section area of the belt, and this is the width of the belt, and this is the thickness of the belt. Now we will try to solve one numerical related to the centrifugal tension and maximum tension, and we will find the application of these terms in the numerical part. So we have a numerical in front of us, so in which it has been asked, determine the width of a 9.75 meter thick leather belt required to transmit 15 kilowatt from a motor running at 900 rpm. The diameter of the driving pulley is 300. Driven pulley runs at 300 rpm and the center distance is 3 meter. Then the density of the leather belt is 1000 kilogram per meter cube. Maximum allowable stress in the leather is 2.5 megapascal. The coefficient of friction between the leather and pulley is 0.3. Assume open belt drive and neglect any kind of sag and slip in the belt. So in this case we have to find the width of the belt. So just now we have covered the formula that maximum tension in the belt is sigma into width of the belt and thickness of the belt. So somehow this formula is being used in this numerical. So firstly we will write all the given thing which are given in the numerical. So the thickness of the belt is 9.75 mm. We will write it in meter, 10 raised to power minus 3 meter. Then power transmission by belt is 15,000 kilowatt. Speed of the driving pulley is 900 rpm because it has been given in the question that the motor which is running the driving pulley is running at 900 rpm. The diameter of the driving pulley of the motor is 0.3 meter, that is 300 mm. Driven pulley runs at 300 rpm. We are assuming the driven pulley by sine 2 and 2, and the distance, center distance between the two pulley, that is x, is 3 meter. Earlier we have covered this center distance topic in the length of belt of the pulley. Now the next thing which is given to us, the density of the belt 1000 kilogram per meter cube. Maximum allowable stress in the belt 2.5 megapascal, that is 10 raised to power 6 Newton per meter square, and coefficient of friction between belt and pulley is 0.3. Now firstly we will calculate here the velocity of the belt drive. The velocity we can calculate with the help of formula pi d1 n1 y 60. So all the things are given to us. d1 is 0.3, n1 is 900 rpm, and this is 60. So after calculating these values, the result comes like the value of velocity is 14.14 meter per second. Now the next thing is power is given to us. So the power of the open belt drive is given by T1 minus T2 into velocity. These things are not given to us and it is given. So power is 15,000 T1 minus T2 into V. We have just calculated 14.14. We assume it as number 1 equation. Now the next thing is to calculate the value of T1 over T2. We have the formula T1 divided by T2 e raised to power mu theta. This derivation we have also covered in the previous lecture. So you can see my previous lecture video to know how we can drive this relation, where mu is the coefficient of friction and theta is the angle of contact between the belt and pulley. So for your understanding, if this is the center of the pulley, this is the portion at which the belt leaves the driver pulley. This is the portion at which belt enters the driver pulley from the driven side. And this angle is the angle of contact. And this angle we assume as alpha. Now to calculate this value theta, we have one more thing given in the numerical itself, that is the center distance. We have the formula sine alpha is equal to r1 r2 minus r1 by x. We can also write it as d2 minus d1 by 2x. So actually d value of d is given to us, so we can convert r2 into d2. Now the value of d1 is given. The value of d2 we can find with the help of formula n2 by n1 d1 by d2. This is the velocity ratio. The value of n2 and n1 are given. N2 is 900 rpm, n1 is 300 rpm. Value of d1 is 0.3. Yes, 0.3. d2 we can find. Okay. So d2 will come as 300 approximately 0.3 multiply by 300, sorry, divide by 900. So value of d2 you can find here. Sorry, here the value of n1 is just I was the little mistake from my side. I will just erase this. Here this is n1 is 900 and n2 is 300. So the value of d2 came out as 0.9 meter. So we put this value in this equation. Sine alpha is equal to 0.9 minus 0.3 divided by 2 multiply by center distance 3. It came to be 0.1. So alpha came to be sine inverse 0.1, and this value is equal to 5.74 degree. Now further, angle of contact for open belt drive is given by the equation 180 degree minus 2 alpha multiply by pi by 180. This multiplication is done to convert degree into radian. So by putting this value 5.574 here, the value of theta comes to be 2.94 radian. Now again we will move back. T1 over T2 is equal to e raised to power mu theta. The value of mu is given 0.3 and value of theta is given as, now we have just find out, 2.94. So by solving this equation, T1 over T2 becomes 2.42. So we can just write as T1 is equal to 2.42 times the value of T2. And we will put this equation in equation number 1. You can see in equation number 1, 15,000 equal to T1 minus T2 into 14.40. So the value here 15,000 T1 minus T2 means 2.42 T2 minus T1 into 14.14. So this is T2. So the value of T2 by solving this equation is found to be value of T1 is 1806. Value of T2 is, just you can calculate. I'm just calculating with the help of calculator. This value comes to be 746. So again, these value we have find out. Now the next target for us is to find the width of the belt. So T is given by sigma into B into T, where T is the maximum tension in the belt. So maximum tension in the belt will be T1 plus Tc, that is the centrifugal tension. Now here the concept of centrifugal tension comes into picture because the overall velocity of the belt drive is 14.14 meter per second. So we have to use the centrifugal tension. Sigma is given, the value of sigma is given to you, it is 2.5 into 10 raised to power 6 Newton per meter square. The value of width we have to find out. The value of thickness is also given. The thickness value is, it is equal to 9.75 into 10 raised to power minus 3. Now T1 we have just calculated 1806. Tc is equal to m into v square. This is the value of centrifugal tension, mass into velocity square. And this thing further you can calculate 2.5 into 10 raised to power, the value comes to be, I'm just calculating the value, it is coming 24400. Now we will separately calculate this mv square. So mv square is equal to mass. Mass is density into volume. Volume is area multiplied by length into v square. V is 14.14 the whole square. And density is given 1000. Area is width multiplied by thickness, and length we are assuming per unit length, so it is 1 meter. Then 14.14 square, 14.14 into, it is approximately 199.93. Again we will put the value of thickness 9.75 into 10 raised to power minus 3, and we will calculate this value, and it is approximately 1950 times the B. So now we will put this value in this equation. Here 1806 plus 1950B 24400B. So further we are solving this equation. 24400B minus 1950B. So B becomes approximately 0.080 meter, or we can also cite it as 18 mm. This is how we can find out the value of width. So you can see that in this numerical we have used all the concept related to the open belt drive, starting from the velocity ratio. Then we have used the concept of the driving ratio between the tight side and slack side. Then the concept of centrifugal tension is also used. The concept of angle of contact we have used, and ultimately we have find out the width of the belt. So in the next lecture, we will start with the cam and follower unit. So stay updated and stay tuned in my YouTube channel. So please like and subscribe my channel. Thank you very much.